Yeah, so the first thing that this is a long session, so I wanted to focus on geometry. And as you know, geometry has basically, it builds upon a few basic ideas. The first idea is that what exactly is a line? So we know that everything starts with a point. Okay, in geometry, it all starts with a point. And a point is something that does not have any directions, any dimensions. Like it has zero length, zero width, zero height, but it is still something that you can identify that that is one point. All right. So it doesn't have any dimensions. That's the basic idea of a point. But you get enough of them, like you join one with another, and then another, and you get a line. All right. Now that line is basically an infinite sequence of different points. Okay. And now, if let's suppose there's another line that crosses this one, right? And it's exactly on top of this one, then they will be very difficult to differentiate from each other, right? They're basically just upon each other. So we can say that one line, which is exactly on top of the other one, could be a longer version of that, a smaller version of that. And all of that basically says that we have scaled the line. Okay, scaling means that you have decreased or increased it. It could, we have studied ratios. So all of that works with ratios. Okay, fair enough. Now, those lines, we already know how to define them in y equal mx plus c. But how this is different, how geometry is different from that is that geometry talks about what happens if another line was to come in here and intersect this one line like that. Now, what happens here is that you have basically divided this space that you had all around this line into two parts. There is one part which is over here, and there's one part which is over here. Similarly, the space below the line is divided into this part and this part. And these we call angles. Angles are basically all the points where two lines join each other. That is one angle. All right, so that's an angle. And the first idea that we have is that total angles on a point, this is a symbol for angle. Sometimes we also write this, on a point are equal to 360 degrees, which means if I were to add this A, B, C, and D, they will all add up to 360. Okay, fair enough. What does that mean? What about just A and B? Now, because A and B are exactly on one side of the line, they will add up to half of that. That is 180. That's our next main idea, that angles on a line equal 180. So for example, if I had this line and I had this line that just came in here, then this one and this one, they will add up to 180. Okay, that's also pretty straightforward. Then we have this idea that, all right, I have this setup, all of these things. And if I drew a line, so I'm deleting this. If I drew a line that was parallel to the line here, like these are two lines, right? So if I had a line that was exactly parallel to this one, but it crossed the other one somewhere else, then whatever is happening in this region will be copied in this region. What that means is that this angle will be exactly like A, and that angle will be exactly like B, and this angle will be C, and this angle will be D. And the reason for that is that A, B, C, and D are all upon the same point from the same parallel lines. Okay, and they have these names. For example, these two, we call them, these A's, we call them, what, do you remember the name of these angles?
Are these interior angles?
These are called corresponding angles. So here's the thing. We have 4 different pairs here. Okay. So should I number them? Okay. No.
Sure.
So if two angles are, so here's the thing. F, X, these are, and Z. These are 3 ways of defining these angles. For example, if I look at angle D and angle B, this one over here, they make a Z, right? These are called alternate angles and they'll be equal. Similarly, if I look at angles B and D, they make a cross, right? So B and D, they make a cross. B is here, D is here. That pair is called vertically opposite angles. And these angles corresponding, we have already seen, they make F. So for example, in this case, if two angles make this shape, that is F, and we call them corresponding angles. And then we have this last pair, which is a C, like this one, this angle and this angle. For example, in this case, you have a C over here. So this C angle and this B angle, these both are called interior angles. And they have another, they're not equal, but they are equal to 180. So 4 things that you have to understand for parallel lines. If you have parallel lines, so if I have this line and they're parallel, this is a way to show them. And here you go. Let me label these 1, 2, 3, 4, 5, 6, 7, and 8. All right. First of all, if you add 1, 2, 3, and 4, will that be equal to 5, 6, 7, and 8?
Yes, sir.
Yeah, because they are both angles on a point, and angles on a point are all equal to 360. Okay. Angle 5 and 6, if you add them up, what do you call that? So there's 2 terms here. One is supplementary and one is complementary. Supplementary angles, they add up to 180, and complementary angles, they add up to 90. Okay. So angle 1 and 4, they'll be equal, right? Why? What's their relation with each other?
Vertically opposite, sir.
They are vertically opposite. So they'll be equal. Yes. Angle 2 and 3 will obviously be the same. Angle 2 and angle 6, what's the relation between them?
Are they the same angle? They're corresponding, I think.
They're corresponding angles. Yes, that is true. They're corresponding angles. And can you identify 2 pairs of interior angles?
3 and 5.
3 and 5, yes.
Yeah, and 4 and 6.
4 and 6, yes. Yeah, so that is how these points relate to each other. All right. So that's parallel lines. Now let's move on to shapes, which we call polygons. Polygons are basically closed shapes. All right. And the thing about polygons is that the simplest one is triangle, obviously. Now here's an interesting thing. If I extend this line here, and I extend this line here, and I extend this line here, and if I were to add these angles up, like this whole angle, and this whole angle, what will the sum of these 3 angles be?
Sir, 180 into 3.
Yeah.
180 into 3, exactly. So you can say that the angles on all the corners are equal to 180, right? 180 times however many sides it has. This is 3 sides, so 3. If I had 4 sides, for example, in the case of a square or a rectangle, then one side will be this line, one will be this line, one will be this line, and one will be this line. Okay. So all of these will equal to 180 times 4. Now here's the thing. If I were to just divide them into 2 parts, one is the angles that are inside, this one, and this one, and angles that are outside. So this one, this one, and this one. Now I can say that basically this is equal to interior angles, the ones that are in blue, plus the exterior angles, the ones that are in green. Right? That's equal to the sum of all the sides, right? Now, here is a theorem that we have to remember. Sum of exterior angles of any polygon, doesn't matter what polygon you have, is equal to 360. If you add all the green angles here, you will get 360. That's the theorem. We don't need to prove that or we don't need to know the reasoning behind it at this stage. We don't need to. So that means this value, the exterior angle, is always going to be 360. And interior angles I can figure out for myself based on this, that it will be equal to 180 n. So interior angles is always going to be 180 n minus 360. Right? Everybody agrees?
Yes, sir, that makes sense.
I have a formula now that tells me if I were to add all the angles inside any polygon, I will know what's their sums. For example, if I had a triangle and I said this is A, this is B, this is C, then A plus B plus C will equal to 180 times 3 minus 360. If I had a square or a rectangle and I name these A, B, C, and D, then A plus B plus C plus D will equal to 180 times 4 minus 360. Right? Now that's my sum of interior angles. And that formula is for that. That if I add all the interior angles, this is the formula I get. Now here's the thing. What if I knew that they were all equal to each other? In that case, I'll simply divide the interior angles by number of sides. So when you have regular shapes, interior angles of any shape is 180 n minus 360. And if it is one interior angle, then it will be all divided by n because they're all the same angle. Similarly, all the exterior angles add up to 360. So if I have one exterior angle, it will be divided by n, provided that this is a regular shape, a shape in which all the angles are identical to each other. Clear so far? Any problems?
No, sir. It makes sense so far.
All right. Now, just by applying these, we can figure out that for triangles, they're always equal to 180 because 180 times 3 is 540. 540 minus 360 is equal to 180. Similarly, for a quadrilateral, the shape with 4 sides, it will always be equal to 360. So that's something that it's easier to remember. So 180 for 3 sides and 360 for 4 sides. Now, here's a very interesting idea. If I had a triangle and I made it like this, so this was my triangle, and I extended this line. Okay. Now, let me call this A, this B, this C. Then let's call this one X. Okay. What is A plus B plus C equal to?
180 n minus 360.
Which is going to come out to be just 180 because 180 times 3 minus 360 is 180.
Isn't it just all interior angles equal to 180?
Yeah, for triangle, yes.
Yeah, that's what I thought.
Yeah, it comes from this point, this idea. Because this will evaluate to 180.
Yeah, that makes sense.
Yep. And what is X plus C equal to?
180.
180. So I can say that A plus B plus C is equal to X plus C.
Ji, sir.
Which means if I cancel C from both sides, I'm left with A plus B equals to X.
So why would X plus C equal 180 again?
Because they're on a straight line. All angles on a straight line are equal to 180.
Oh, yeah, that makes sense.
Okay. And
Yeah.
this is called exterior angle theorem. We use it all the time in triangles. Basically, you pick any one exterior angle and it is equal to the sum of two interior angles, the other two. Let me give you an example and that will make it more clear. So for example, if I have this triangle and this angle is 40, this angle is 60, and this angle is 80. All right. And this is an extended angle. Now here's the thing. 80 plus X should equal 180. And 80 plus 40 plus 60 is also equal to 180. In other words, this angle is being subtracted. If I subtract it from interior angles of a triangle or whether I subtract it from angle upon a straight line, I'm left with the same value, 100. So I can say that if I had this X, this will equal to 40 plus 60. So angle outside is equal to the other two angles inside.
Okay, yeah, that makes a lot more sense then, sir. Yeah. Because then you do 60 plus 40, and then you could just do 180 minus x, and then you'd find out.
Exactly. Moise, do you understand this?
बहुत easy है, समझ आ रही है.
ठीक है. Now do this question. I know this angle is 100. I know this angle is x, and this is 3x. Can you figure out what 3x is? What x is?
So is 3x equal to 180?
3x equals to 180. No, 3x equal to 120. Let's make use of this idea. So first of all, there are multiple ways of approaching this question.
So it x equals
40.
X is 40, yes. So one way I would approach this question is that this one is 80 because that's 100, so this is 80. And I know that 80 plus x should equal to 3x. So 80 is equal to 2x and x equals to 40. How did you do it? Same method?
सर मैंने लंबा वाला किया था जो हम ओ लेवल में करते थे.
पहले आपने ये
180
निकाला 180
minus
minus 3x किया. हाँ. और फिर आपने वो 80 किया, फिर उस सबको ऐड किया, which means आपने ये थ्योरम यूज नहीं किया. So we should use this. Okay. All right. Let's do a question that sums everything we have studied so far. थोड़ा सा technical सा सवाल है. Let's do it. This line means that this is parallel. Okay, I just drew it again. And this means angle. Okay, so what's your process?
सर वही वाला जो अभी हमने किया था. Lines parallel है तो जो angle ABF है वो भी 40 होगा. So 70 plus 40.
Exactly. So this angle is also 40. And then because this x is 70 plus 40. Exterior angle is sum of two interior angles. तो हो जाएगा इससे. ठीक है. So yeah. Now building on that, can you try doing this question?
36?
Yeah, it is 36. So what was your approach?
Walaikum assalam, sir.
I'm saying, what was your approach? So what I would do is that first of all, I know that this is a pentagon, 5 sides. So 180 times 5 minus 360 will be one angle, and this will be divided by 5 because I want to find just one angle. So this is going to give me what, 720 over 5. So that's 108. 108. 108 कैसे होगा ये?
So मैं 360 divided by 5 कर हाँ ये किया था मैंने.
This is not 720. This is 360. Okay. No, it is 540. Acha. So this is 108. This is also 108. That gives this 72. X plus 2 times 72 is equal to 180 for a triangle. So x is equal to 360. Yeah. Okay. So we're done with angles. This is all you need to know about angles. I've sent you a PDF, right? On that PDF, there's the first section for angles. Try doing as many of those questions as you can. Let's take 10 minutes for that. Okay? And then we'll move on to triangles.
So question 6 कैसे करते हैं?
जी इब्राहिम क्या कह रहे हो आप?
Question 6 कैसे करना है? Question 6 नहीं समझ रहा मुझे.
All right, hold on, let me see. Here we have to deal with pairs of angles, not just one angle. That's the thing. Okay? Okay, so what is the value of A plus B? Turns out that A plus B should equal 100. Does anybody know why that is? Can we find this angle?
Oh, never mind. समझ आ गया.
That's 80, na? So that means 80 plus A plus B should equal 180. Another way of doing the same question would be that you know that because this is 70 and 30, this angle should be 100 because it's sum of these two angles, which also means it's the sum of A and B.
So the answer would be B, right?
The answer is B, 100. Yes.
Yeah. Okay.
All right. Now let's talk about triangles. The first idea of triangles is that about the length.
आपकी screen नहीं share हुई.
Hold on. Let me share it again. Thank you. Yeah. So the first idea about angles is that, triangles is that the sum of all three angles is 180. We already know that. But there's another one. And that comes from the idea of how we make triangles. For example, if I know that one triangle is 7, one side is 7, the other side is 10, and the other side is 8, how will I actually construct it using a compass? So what I'll do is I'll first draw a line of 10 because that's my longest side. I don't have to, but I could. And then I will put the compass here and draw a circle or an arc like this for 7 sides. Okay, the length would be 7. But then I'll put the compass here, open it for 8, and then put an arc like that. And whenever they meet, that point is 7 from this point and 8 from that point. And that is how I will know that I've drawn the triangle. Now, can you think about it? Now, this only depends on the idea that both of these arcs intersect with each other. If they don't intersect, then there is no way that I could get a third point that makes a triangle, right? So how should I open the compass when I'm putting it here to make that triangle? How wide should I open it? Okay, imagine I did the same thing, 10 centimeters here. I put the compass here and I put the compass here. I draw 2 circles, one with the center here and one with the center here. If I don't want the circles to intersect, what's the biggest radius I can get for those 2 circles? For example, if I draw this circle and its center is over here, and I draw another circle and its center is over here, then they will intersect, right? At what length will they never intersect? Or intersect at just one point? What radius would it be that they intersect at just one point?
5, sir.
5, yeah. And if the radius is less than that, then the circle will never intersect, right?
That's true, sir.
That's true. Now, the reason is that why am I using circles? Because whenever we use a compass to draw a triangle, we are basically using circles. When I draw an arc, it intersects the other one. And that is how I know that this is my third point of the triangle. And if the radius is less than 5, then they will not make they will not meet for the third point. Which basically gives me the idea that if this side is 4 and this side is 3, then these circles will never intersect. And so I will never get a triangle. I feel like you haven't worked with compasses in a while. That's not important. The important idea here is that whenever you're making a triangle, and I have these 3 sides, A, B, and C, if I want it to be a triangle, then A plus B should be greater than C, so that I'm getting 2 arcs that do intersect. If they're equal to the radius, or if they're equal to half the distance of C, or if they add up to C, if A plus B is equal to C, then they will meet over here, which means they will not be a triangle. So when I add these 2 up, they must be greater than the third side. So sum of any 2 sides should be greater than the third side. That's the first idea of a triangle. Okay? So tell me, can you try to solve this question using this idea?
So wouldn't it be 6?
What do you mean it would be 6?
So like it says how many integer values are possible for AC, and since
Yeah.
the sum of 2 has to be greater than
The third.
And so 7. So like 6 is less than 7, sir. So that's the max possible.
So I could get a 6. I could get a 5.
You could get a 4, so you do a 1.
Not 1.
Not 1?
Yeah, because if I took 1, then 1 plus 3 is equal to 4.
Sorry, मुझे समझ नहीं आया.
So here's the thing. If I have a triangle, then A plus B should be greater than C, which also means that A plus C should be greater than B, or B plus C should be greater than A. The idea is that sum of any two sides should be bigger than the third side, no matter which side you pick. Okay, so in this case, if 3 plus 4 is greater than C, then that means C is less than 7. The third side has to be less than 7.
Okay, so that makes a lot more sense.
Right? But it also means that C has to be greater than 1. Why? Because 4 plus C is greater than 3. I don't really need to use the third one, although that will mean C is greater than minus 1. लेकिन वो तो एक ही बात है ना, मतलब if C is greater than 1, then C is obviously greater than minus 1. So उसकी जरूरत नहीं है. But the idea is that sum of any two sides should be bigger than the third side. Let's move on to, there is another triangle that we talk about that's called isosceles triangle. You know what isosceles triangles are? Isosceles is when two sides are equal to each other. So for example, if I have this triangle, then this is A, then this is also A, and the third one is B. This is an isosceles triangle. But there's a special case of isosceles triangle which we call equilateral triangles. In equilateral triangles, all sides are the same. And basically, this also implies that angles are also equal to each other. They're all equal to each other. They're all the same. Now, here's the thing. Whenever you divide the sides in a ratio, you're also dividing the angles in that particular ratio. Okay? And the idea here is that the smallest side is opposite to the smallest angle, and the largest side is opposite to the largest angle, which means that if this side is A, then this side will be, the angle will equal to this angle because they are both the same sides. The angle will also be equal. Okay. So that means if A was smaller than B, then this angle will also be smaller than the angle of B. ये बात समझ आ रही? What if I know that I have an isosceles triangle and one angle is 50? What are the other two angles?
You know that, sorry sir, could you repeat that?
I know it's an isosceles triangle.
Okay.
And one angle is 50. What are the other two angles?
Would they both be 65, sir?
They could be 65.
They could be 65, okay.
Yeah.
Okay, they could be 65, and so what was the value you gave?
50.
Then it could be 80.
Yeah, very good. So basically, we have two possibilities. One is that the angle 50 that I've told you is the angle that is equal to the other side, which means that this angle would be 80. And the other is that if I knew that 50 was one angle, then that was the angle that was not equal. So then this would be 65. So those are two possible values. The third angle can either be 80 or it can be 65, depending on how it works. Okay, good work. Try this one. ABC is equilateral.
120 से ज़्यादा इतना मैं बता सकता हूँ.
सही है क्या?
We have to sum up all these angles, J plus K plus L plus M plus N plus O. And the big hint is that it's actually a really useful hint that ABC is equilateral.
So would it be 120?
No, it won't be 120.
More than 120 ना. J और O तो 60 हो गया तो 120 साइड.
Yeah, J and O is 120. Yes, you add them up, that's 120.
सर ये K plus L 180 और M plus N भी 180 नहीं है साथ साथ?
Exactly, they are also
380
on the straight line. Yeah. So this pair is 180 and this pair is 180. This is 60, that is 60. So you add them all up. That's what? 180 plus 180 plus. No. 180 plus 180 plus 120. That is 480. Yes.
Oh, yes.
Clear?
और फिर उसको और फिर बस ये आंसर है.
यही आंसर है. Yes, exactly.
तो फिर सर फिर C निकालना होगा. C का क्या आंसर होगा?
C तो नहीं निकालना. उसने कब कहा कि C निकालो?
नहीं मैं कह रहा हूँ कि अगर वो कहते हैं कि C निकालें इस सिचुएशन में तो कैसे निकालते हैं?
वो 60 है ना?
60, we already know that. It's an equilateral triangle.
Equilateral triangle में हर एक एंगल 60 होता है.
Yeah, exactly. Because all sides are equal, all angles are equal. And the total is 180, so 180 over 3. Okay, now we talk about right triangles. Okay, now there are two things we need to know about right triangles. Obviously, Pythagoras theorem. Pythagoras theorem says that in a right triangle, you have three sides, and a squared plus b squared is equal to c squared. And that basically relates the lengths of the three sides. And this is the biggest side, which is basically called hypotenuse. This also implies that the angle opposite to hypotenuse is also the biggest. And in any right triangle, one angle is 90, so hypotenuse is opposite to 90. All right? Clear? Ye to pata hai na? Let's do this one.
So isn't this Pythagorean theorem?
It is. Yeah, it is.
Is it 4?
No, it's not.
Sorry, 2.
It's not. It's not a whole number.
It's not a whole number.
Yeah, it can't be a whole number.
Sir, 2.5 है height.
It won't be like it's a recurring decimal. It keeps on going. It's an irrational number.
तो फिर सिर्फ 5 है.
Irrational number. So here's how we do it. We know that base is twice as long as the height. So if this is height, then this is 2x. So 2x squared plus x squared is equal to 20 squared. That means 4x squared plus x squared is equal to 400. 5x squared is 400. X squared is 80. Okay? So what's the height? Height is x. So that is x is square root of 80. And 80 is what? 16 times 5. So it's 4 square root 5. We have already seen this, right?
So it was 8.944. I was on 8.966 at the time.
No, you don't have to give your answer in decimals. You can just leave it like that.
सर ये तो थोड़ा सा मुश्किल हो गया ना, अगर हम सिर्फ लिख दें 8.9 यानी कि 9 तो फिर सही नहीं है.
नहीं, क्योंकि 8.9 नहीं है ये. It is 4 square root 5.
तो फिर से 9
8.9 is smaller than 4 square root 5. Approximate नहीं करना है आपने.
अच्छा.
Now there, you will see that there are a few triangles that come up multiple times. For example, there's a triangle that is 3, 4, 5 triangle. A 3, 4, 5 triangle is a right angle triangle with this dimension 3, 4, and 5. And you will see that you can also get a triangle 6, 8, 10, or you can get a triangle 9, 12, and 15. What's happening here? You're multiplying these with different numbers. Turns out any three triangles or any three sides that can be simplified to 3, 4, 5, they make a right angle triangle. And this is called a Pythagorean triple. Okay. So a Pythagorean triple, if you can get that, that clearly shows that this is a right angle triangle. And you will see multiple examples of different Pythagorean triples in your SAT. Now, you have to memorize 3 of them. One is 3, 4, and 5. The other is, I think, 8, 12, 13, and 5. So 3, 4, 5, 5, 12, 13. और एक 8 वाला होता था. 8, 15, 17. And sometimes we get 7, 24, and 25. Anything that's a multiple of these is also a Pythagorean triple. ठीक है? And you will see these multiple times. The first 3 तो काफी दफा आते हैं. तीसरे वाला कभी-कभी आता है. Okay? So you can scale it up. For example, if you get 20, 48, and 52, that's also a Pythagorean triple. Because if I divide them all by 4, I get 5, 12, and 13. Okay?
Sir, how would that make sense then?
How did it work? So basically what you have to do is whenever you get 3 sides of a triangle, like a right angle triangle, you can just see if it is a multiple of these 4. For example, if I give you a random number like 12, 16, and 20, just see, they all divide by 4, right? So that gives me 3, 4, and 5. You know right away it's a right angle triangle.
Okay, that makes more sense.
Because it's one of these. Okay. Then we have special right triangles. There are 2 special right triangles which you need to memorize. One is called isosceles right triangle. It is isosceles because these 2 sides are exactly the same. This angle is 45. Sorry, and this will also be 45. Now here's the thing. If this side is x, this side will also be x because they are isosceles triangles. But that means this is x square root 2. This idea comes from Pythagorean theorem. Okay. So that means anytime you get a right triangle with these dimensions, you know right away to apply this special right triangle. The other special right triangles that you should know about is called a 30, 60, 90 triangle. This is a triangle in this angle is 60, this angle is 30. And what happens here is that the side opposite to 30 is x, this is 2x, and this is x square root 3. For example, here's a question. They give us this triangle, and they're like, this is 45, this is 45, this is 4, and this is 90. What is the area of this triangle? How would you approach this question?
Sir, हम कौन सा कह रहे हैं और क्या निकालना है?
We have to find area of this triangle.
Sir, I think it's 1/2 into base into height into sin theta.
Sin theta यहाँ पे कहाँ से आ गया? सूरत ही नहीं है.
Sir,
Right triangle.
It's just base times height, 1/2 base times height.
No, in this case, it is. We don't need sin theta. We can use sin theta, and that will give us sin 90, which is 1. We don't need that. But obviously, you need the base, you need the height. And what you can do is that you can relate this to the special right triangle that you have over here. The special right triangle tells me that in any isosceles right triangle, the 2 sides are x and x. And the third side is x square root 2, which means 4 is x square root 2, which means x is going to be 4 over square root 2, right? And now I'll apply the formula 1/2 into base, which is also 4 square root 2, into height, which is also 4 over square root 2. And there you go. It is going to be 16 over 2 times 2, which is 4. Sorry, 8. That's my area. नहीं 4 ही आता है. समझ आया क्या हुआ? Or did I go too fast?
Sir, इसमें sin cos tan भी लगा सकते हैं ना?
आप लगा सकते हो, but हमारे पास टाइम नहीं है और कैलकुलेटर भी नहीं है.
सर, फिर आपने कैसे किया ये?
So you have to memorize these 2 special triangles. ठीक है, इनको एक्चुअली में आपने मेमोराइज करना है. These are triangles in which one is isosceles, which means उसकी एक साइड x है, दूसरी भी x है, और तीसरी is x square root 2. That is isosceles right triangle. And there is the second one in which you have 30, 60, 90. That's the angles. And in that case, opposite, the smallest side is obviously going to be opposite to the smallest angle. So that side is x. The larger side is 2x, and this side is x square root 3. ये आपने डायमेंशन याद रखनी है. तो अगर मैं आपसे कहता हूं कि एक ट्राइंगल है जिसकी स्मॉलेस्ट साइड इज 4 और 30, 60, 90 की ट्राइंगल है. Tell me the other 2 sides. So what you'll do is you'll be like, okay, this is a 30, 60, 90 triangle. I know sides are x, x square root 3, and 2x. So if this is 4, this will be 8, and this will be 4 square root 3.
So it's a bit like complex, so you do it really quickly.
I'm sorry?
So you do it really quickly.
Oh, I'll slow down. So remember that in any special right triangle, this is the dimension, this is the ratio of dimension. थोड़ा try कर लेते हैं. Go on. Let's say we focus on the 30, 60, 90 triangle. आपने बस मुझे ना उसकी sides बतानी है. This is 30, this is 60, this is 90. The standard triangle is x, 2x,
X squared.
x squared.
Yeah. Okay.
Okay. Now, if I have a triangle in which this side is 2, what will be the hypotenuse? 4, right?
Yeah.
And the third side will be 2 square root 3.
Yeah. Which would be.
Yeah.
Well,
Now,
yes,
if
it's
I-
2 square root 3.
Right? If I change this side to 10, then
20.
20 and 10 square root 3.
Yeah. But then, like, do you have to solve for like 2 square root 3 or 10 square root 3 as well, or do you leave it as that?
You leave it as that. That's the side. Of course, if they ask you for an area, then you use these values. If they
Okay.
ask you for a ratio, you use these values.
Okay.
Okay, let's try it one more time. What if this side is 10?
Then you'd have 5. And then you'd have 5 square root 3.
Very good.
Okay.
So
that
that's how
makes-
you do it. Okay, that's how you do it. Similarly, let's try the 45 wali triangle. Moiz, dekh rahe ho? So this is the 45 wali triangle. In this one, you have x, x, and x square root 2. That's the standard. Now, if this one is 4, then what are the other values? 4 and 4 square root 2. Clear? Now let me change that. Let's say I have 9 here. What are my other two sides?
9 and 9 square root 2.
9 and 9 square root 2. Very good. Now let me change that a little bit. What if my sides were 3.5 and then what are the other two sides?
So wouldn't it be the same thing? 3.5, 3.5 square root 2.
3.5 square root 2. Okay, let's try one more time. What if I know that the area of this triangle is 12? Now what?
Then you know that 1/2 base times height, so that you know. X.
And I know that base and height are both x, right? So
Yeah.
1/2 x squared is 12. So x squared is 24. So x is going to be square root of 24.
Yeah, I was trying to work it out mentally.
Yeah. So this one is 24. This one is also square root of 24. And this one is square root 24 square root 2.
Oh yeah, okay.
Okay. So then, of course, you can simplify this. That square root of 24 is what? 2 square root 6. This is also 2 square root 6. So this becomes 2 square root 12, which is 4 square root 3. But that simplification, we have seen that in indices. The main idea to remember here is how to work out a special right triangle. All right, let's do an example of this.
So I think I got lost here.
Let's try this. So, have you made any progress? Like I know this is a
60,
right triangle.
Yeah.
It says 60, 30, 90. So if this is 10, this will be 5.
Yeah.
And this will be 5 square root 3.
Yeah.
Okay. And then they're saying, what's the ratio of AC to CB? Okay.
That's where I got stuck. So I got to this part.
Yeah. That's fine. But they're also saying that AD is equal to DC, which means that this is 45, 45 triangle.
Okay.
Okay? Which means if this is 5, then this is also 5. And this whole portion is 5 square root 3. Okay. Now, if that is 5, what will this one be? 5 square root 2. Right? It's a 45, 45 triangle.
Yeah. That'd be 5 square root
And
2.
now you have the sides. One is 5 square root 2. And the other is 5 square root 3 minus 5. Do you get that?
Yeah.
You don't sound so sure.
So a bit slow right now. I'm just trying to
That's
process.
okay. That's okay. Take your time.
सर हम बाकी जो है कल कर सकते हैं, अभी मुझे जाना पड़ रहा है।
कल नहीं, ट्यूसडे को कर सकते हैं।
जी जी, ट्यूसडे को कर लें सर।
Yeah, sure. Tuesday is fine with me.
Sir, could you like give us like the whole like document or database of like problem sets that we can do?
I've sent you all the geometry problems.
No, sir, I'm talking about like for everything, for all topics.
For all topics, okay. I'll look it up.
Also, sir, like the answer keys, where do we get those from? Because you've given us
Answer
problem sets, but we don't have the answer keys for
Oh
them.
yeah, I'll check about answer keys as well.
Yeah, because like say I want to like really crunch like I think like a solid 2 hours every day for the next 2-3 weeks. Like
I
I'm
think
freeing
that
up
will make,
time to study.
that will make it much easier, yeah.
Like yeah, I'm using Khan Academy, I'm using Albert, and also like I have an old Princeton review textbook, but I don't think I'm gonna use that because it's from the old format. So yeah,
Okay.
I'm trying to crunch as much as possible. So if you could provide those, it would be really helpful.
All right, I will.
As far as this goes, sir, like just could you send a recording later, like whenever you get time to?
Of course I will. So we are done with these right triangles. The only triangles that are left are similar triangles.